So today we're going to do geometric reflections. There are 6 types of reflections that we have to know how to do. We need to know how to reflect over the x and y axes, over the line y equals x and the line y equals negative x, and over any random vertical or horizontal line. You can reflect over any line, but it's way more tricky than over those 6. Those 6 are very well defined, so those are the 6 we're going to start out with. A reflection is a transformation in which every point from the pre-image maps to its point in the mirror image on the other side of the line of reflection. Each point on the pre-image will be the same perpendicular distance from the line of reflection as its image. So, when we have our xy axes, if we have a shape, and we're going to reflect it through the y-axis or over the y-axis, then these points need to map to their mirror image the same distance from the line. I'm going to try to draw that heart in the same place over here. And so each of these points would reflect all the points of the heart on the right would reflect to the points on the left-hand side of the y-axis. The line of reflection is that line that we are reflecting over, in this case the y-axis. And that's what we're talking about. So why are these 6 things well defined? Well, we're going to start with the first 4, because we can tell you exactly what those points do. If a point AB is reflected over the x-axis, then its image is the point A, negative B, the opposite of B. If a point AB is reflected over the y-axis, then its image is the point the opposite of A, B. And if A, B is reflected over the line y equals x, then its image is the point B, A. This one is hugely important. Reflecting over the line y equals x is how you get graphs of inverses. Inverses being very important as you move along mathematically. So you're going to see a lot of reflecting over the line y equals x, hopefully in Algebra 2. And the last one, if A, B is reflected over the line y equals negative x, then its image is the point negative B, negative A. So let's just do a few. Draw the reflection of each. So we're reflecting that triangle ABC over the y-axis. So where are our points? Point A is the point 2, 2. Point B is the point 5, 2. Point C is the point 5, 4. And so when we reflect those points over the y-axis, here's our y-axis. And so we're taking our points A, B and reflecting them to the opposite of A, B. And so 2, 2 becomes the point negative 2, 2. The opposite of the x-coordinate, the same y-coordinate. The point 5, 2 becomes the opposite of the x-coordinate, negative 5, the same y-coordinate, positive 2. And C prime, the image of C becomes the opposite of the x-coordinate, negative 5, the same y-coordinate, 4. And there is the image of triangle ABC. When we reflect over the x-axis, so we have the same triangle, but this time we're going to reflect over the x-axis instead of the y-axis. So we are reflecting what we commonly think of as down. Our same 3 points, but now over the x-axis. So the x-coordinate is staying the same, but the y-coordinate we're taking the opposite of. So we get A prime is the same x, the opposite of y. B prime is the same x, the opposite of y. And C prime is the same x, the opposite of y. And there's our reflected image over the x-axis. What is the length from A to the y-axis? So here's our point A, 1, 2. What is the length from A prime to the y-axis? 1, 2. They are both the same perpendicular distance away from the line of reflection. So that perpendicular distance part is important here. The distance from our line to the point is defined by the perpendicular. So when we go to the other one, we're looking for the perpendicular, but this time, since we're reflecting over the x-axis, our perpendicular goes this way. It's still 2, but this time in the vertical direction instead of the horizontal direction. You have the same perpendicular distances. We are eventually going to define the distance from any point to a line as the perpendicular distance. We're going to have a lot of fun figuring out how to find this point on the line when it's not just vertical or horizontal, when you have random lines with points. How do you figure out what this distance is? That is something we're going to wind up doing in this class. How do you find this point and get this length that's perpendicular there? So that's going to be an extension of this eventually. Quite fun. Starts here with these thoughts about vertical and horizontal lines and those perpendicular distances. So we're going to reflect over some other lines, reflecting over the line y equals -1. So first, what is the line y equals -1? When you have y equals a number, that is the definition of a vertical line. A horizontal line, sorry. Our y's equal -1. So the line we're reflecting, that's +1. Let's try again with -1, shall we? We're reflecting over the line y equals -1, which is down here, a horizontal line at -1. So if we're reflecting that triangle ABC over it, 1, 2, 3, 1, 2, 3. There's A prime. I mean, it really is just that easy. B prime, C prime, and we're done. A prime is 2, -4. B prime is 5, -4. And C prime is, what is that, 5, -6. All of these having to do with the distance away from the line of reflection. So let's reflect part D here over x equals 3. X equals 3 is the vertical line running through 3. So there's our line of reflection, the line x equals 3. Notice how part of our triangle is now on the left-hand side, and part of our triangle is on the right-hand side of the line. So when we reflect these, we're going to have to get both parts in the right place. So point A is going to reflect over the line this direction for A prime. Point B is reflecting over that line to become B prime. And point C is reflecting over that line to become C prime. So our image is that triangle, with A prime being the point 4, 2, B prime being the point 1, 2, and C prime being the point 1, 4. All of these have to do with length, so calculating some lengths real quick. What is the length from A to the line y equals 1? That was the 1, 2, 3 that's over there. A prime to the line y equals 1. 1, 2, 3. When we're counting length or distance vertically or horizontally, all you have to do is count the number of spaces, the number of units. Doing the same thing for D, what is the length from A to the line x equals 3? That's 1. What is length from A prime to the line x equals 3? That's also 1. So we've spent a little over 11 minutes here. I'm going to leave you to explore reflecting over the line y equals x and y equals negative x while you try the homework problems. We've only had less than 12 minutes of notes, so I want you to try some of those. We're not going to have a lot of time in class for them tomorrow, so you should attempt the problems. If some give you some trouble, we will go over those in class tomorrow, but know that you're not going to have a lot of time in class just to work through all the problems, because you got plenty of time right now after only 12 minutes of notes. Have a great night.